Hello friends, good morning. Welcome to the new video of the Nukkadcode, and in this video we are going to learn about our object, that is how our object looks from inside. And this is to understand polymorphism in detail, that is when we are going to learn about overloading and overriding, then this will help you a lot. So that's why we are going to learn about the structure of object in a very detail. So let's understand how our object looks like on the heap and what different actions or what different methods can be called by using references and many things. Okay, so let's understand the structure, that is how our object looks on heap. So to understand this concept, let us consider our previous class, that is stack class. So here you can see we have our stack. So for now let's concentrate on this class. So here we have our stack class. Okay, and this stack is an animal. So this stack extends animal class. Okay, and this animal is an object, because object is superclass of all the classes. So we can say that animal is also object. Okay, so this is our structure. Here it is stack. Now suppose in animal we have some methods that animal can do. Animal can eat, so we have eat method. And animal can sleep also, so we have sleep. Animal can walk, so let us suppose we have a method walk. And when I do not write anything, any accessible file before any method in this diagram, that is UML, so always consider it as a public method so that it can be inherited. Okay. So these methods are there. And suppose stack also defines one more method, as eat is inherited here, sleep is inherited, walk is inherited. These three methods automatically available to the stack class. And stack also defines a method, that is suppose make noise. Okay, it defines make noise method. Now let us understand about this, how our object looks. So let us go and consider the first line of making, that is creating an object. So when we write stack, let me write it from left to when we write stack s is equal to new stack, what happens at this line? At this line what happens? A new object is created. A new object is created in the heap area. Suppose this is heap area. So a new object is created in the heap area, and this is stack. This is a stack object. Okay. So let me write it here, stack object, and it is referenced by this stack reference S. Okay. Now think of it, how these methods are inside here. Okay. So what we have this stack method. This stack method will have a make noise method. Make noise method. Okay. And there are three methods that are inherited from the animal, that is eat, sleep and walk. So stack is going to contain this animal portion inside this stack object. So suppose we have here, we have our animal portion. So let me write it as animal portion. what does mean by animal portion? That is the methods that are inherited from the animal class. So here we have eat method, walk method, and sleep method. These three methods are inherited from the animal class. And then what happens? We have object class, and this animal object contains portion of object. So let me write it as object. And what happens? Object class has methods such as wait, notify, equals, hash code. These methods. Okay. So basically, we can say that when we create a stack object, then what this object contains? This object contains all the methods that are inherited from its parent, and also all the methods which it declares by itself. So when we talk about stack S, this stack object, then it is going to contain all the methods. It is going to contain all the methods that are present in the object class. It is going to contain all the inherited methods that are available from the animal class, and also it is going to contain all the methods that it declares. Okay. So for your reference, I have created a simple. Here you can see I have created a simple shampoo. So you can say it is a cone. So here you can see on the top of it I have object class. This is object class, and after that it is animal class, and inside it I have written camel, but since we are going through stack, so here it will be stack. Okay. So object is on top of it. So we can simply, if we create a cone like this, we keep the cone. Then we can say that the outermost portion here, it is stack, and this green portion becomes here. This green portion is animal, and this yellow portion drops like object. Okay. So simply it is, here is stack portion, here is animal portion, and here is object portion. The same way as we have here. So I think by using this code, I am able to visualize this object structure, so that you can understand how our stack object looks. Okay. Now let us get in detail about this. Some more detail. What happens and how? What happens when we assign this reference to animal or object? What is going to happen? So now suppose we have a reference object O. One second. Before going to that, let's understand one more thing. Before going to this. Understand one thing. When what methods we are able to access at this time. Suppose when I write, I'm going to write s dot. Then what by using this reference, what methods are available to this stack reference? What method? So all the methods of object, that is, when I write s dot, I can be able to access the method equals, hash code, wait, notify, other 11 methods are other methods of the object class, and plus we are going to access each methods. We can access walk method, we can access sleep method also. Plus we are going to access this extra make match method. So all these methods are available to this reference. I think you have no doubt that all the inherited methods from the parent are easily visible to the subclass in from that is, if we create an object for animal, then all the object class methods, inherited methods are available to animal. And if we create a stack object, then all the objects, all the methods, inherited methods are available to stack from animal and also from the object class. So I think you got the basic idea of how our object looks. Now friends, let us go and understand some interesting scenarios. Let us walk through some interesting scenarios. So suppose I create an animal reference, animal, animal. Okay, I just created an animal reference. Now what I do, since this stack is a animal, so simply I can assign this stack to animal. Okay, so what I do, I assign this reference s to animal. Now what will happen? This animal is going to point to the stack object. Okay, is it clear? Okay. And also suppose I have a reference for object and I do the same, O is equal to S. Then what will happen at this line? This O will also point to the stack object. So we can say that this S is pointing to the same object, animal is pointing to the same object, same stack object, and this O is also pointing, that is referencing to the same object in the heap. But think what will happen when we are going to access the method. How much portion of this object is available to this animal reference? How much portion of this object stack object is available to this object, that is O reference, object reference. Now, now I think you have made your decision. But before going to understand what portion of the methods are available to this reference object, animal, S and S, let me have you back in the story of this Stanley, that is the character played by Jim Carrey in the movie Mask. So think of the character Stanley. In the trailer you can hear that the narrator tells that Stanley is not a man he used to be. Means all the behavior of Stanley are gone after having the mask. Now he is crazy. He is simply crazy, and he can do all the crazy things in the world. He can fall off the building, and he can make crazy structures in the air with the smoke, and he can do anything. Simply, he can do anything. His behaviors are completely changed than the behavior of Stanley. Okay, I think you got it. If someone sees masked man, that is masked Stanley, he will only be able to see the behaviors of the crazy masked man. That is all the crazy behaviors. He is not going to see the behavior of original Stanley, that is going late to office, coming late at night, and the crazy thing, the boring thing. Okay, so the same thing lies here. That is, after getting masked, the same concept lies here. When we assign this object S, that is stack object, when we assign this stack object to O, then what behaviors are we able to see? We are able to see the same in the case of Stanley, that is masked man. After getting masked, we can see someone or anyone can see only the behavior of masked man. No one knows about how Stanley was originally before mask. No one have any idea. The same thing happens here. When we assign the stack object to object, we are going to access, that is, we are going to access only the behaviors of object, that is object portion of this stack object. It is as simple as that. In the case of Stanley, after getting marks, his behavior becomes crazy. The same thing applies here. We can only see the crazy behavior of that. The same thing here. If we assign stack object to object, we can see only the behaviors of object. If we assign this stack object to animal, we can see only the behaviors of animal. And if we assign this stack object to S, that is stack object stack reference, we are going to see only the behavior of stack. Okay, since this stack is whole the object, so we are going to see all the behaviors for a stack object. So all the behaviors are available for this stack, but for animal reference we are going to see only the animal portion. Only the animal portion, that is when we write here animal dot, then what will happen? Here we are going to see only animal behavior, that is what animal have: eat, sleep, walk. These three behavior. But one thing more, since this animal inherits all the methods from object class, that is hash code, equals and other methods. So with these three methods, eat, sleep and walk, this animal is also able to access the object class, but not this method make noise, which is stack specific. It is not animal specific. So all the methods are available to this animal reference except stack specific method here make noise, that is make noise will not be available here. Now let us think of object. The same thing. In case of object, we are going to access only object related behaviors, that is object portion of this stack object. When we assign this stack will behave like an object. In case of animal, this object will behave like an animal. We can see only an animal, we cannot see a stack object. When we assign this stack to object, now this stack will only behave like an object. So how will object behave? It will have these behaviors, that is equals, hash code, wait, modify and other methods, that is other behaviors. So same thing, if we do here o dot, then what will happen? We are going to access only object related behaviors. We are not going to access any animal related specific behavior or any stack specific behavior. So what will we be able to see here? We will be able to see here only this object related behaviors, that is methods, or equals, hash code, wait, modify, others, all the methods that are declared in the object class. So let me write here the important conclusion, that is with this reference here it is animal reference and here we have object reference. Okay, so with references, that is parent reference, here in case of animal, stack is stack. Here in case of animal is parent of stack. So in case of parent reference, only parent specific behaviors are available. Only parent specific behaviors are available. So friends, we have done a lot of talking. Now let's do some code here. So here I have already written animal method which we talked in the theory portion. So here in animal class we have eat, walk and sleep method, and in the stack we are having an extra method, that is make noise, and it is extending animal class. So all the methods of animal will be available to this. So let's see if it is available or not. So first of all, let's create an animal object. Okay, let's start with stack one. Stack s is equal to new stack. Now let's have s dot. Then let's see what methods are available. You can see here. You can usually see here we have this eat, sleep and walk method. These three methods are from animal. You can see here animal, and here animal, and also here animal. And other methods you can see here clone, equals, finalize, get class, has code, notify all, to string. Many methods, wait, and other methods are from object class. Okay, and there should be one more method from the stack, that is make noise. So let's see that also. So in this stack here you can see we have a method from stack. Okay, so now I think you are here. Means when we create as object, then we are inheriting all the objects, all the methods from the animal and stack. Okay, now let's come to our theory portion, that is let's assign this s to a. Okay, so now this stack is assigned to animal reference. Now let's see what is the same. Yes, here you can see eat, sleep and walk methods from animal. Okay, and object class methods are available, but you can notice that there is no make noise method available for this line. Okay, so let me write it here. Assigning stack to animal. Okay, so you saw that at this line we are not able to access the stack portion, that is make noise method of the stack object. Okay, now let's assign this stack to object. And let's see how many methods are available to it. So here you can see only the object class methods are available and no animal or no stack specific methods are available. So I think the point is clear. Okay, so thank you friends for being with me. This was all regarding the structure of the object, and I hope you learned a lot about